Hi, welcome to video lecture series on CS22076 server-side programming. Today, we are going to learn about JSP architecture in detail. First, we will see about the tools needed to run JSP pages. JSP is a powerful technology used to create dynamic web content by embedding Java code directly within HTML. It allows developers to build interactive and data-driven web pages while keeping the presentation layer simple and flexible. Unlike traditional static HTML, JSP can respond to user inputs and interact with databases and generate customized output for each request. To run a JSP page, a JSP engine or container is required. This engine is part of the web server and is responsible for translating the JSP file into a servlet and then compiling it and executing it to produce the final response. Without this container support, JSP pages cannot function because the translation and the execution process rely entirely on the server environment. Popular servers like Apache Tomcat include a built-in JSP container, making deployment easy for developers. Tomcat automatically converts JSP file into servlets and manages their lifecycle efficiently. This combination of Java's power with the server-managed execution makes JSP a widely used choice for building scalable and dynamic web applications. A JSP container is an essential part of any Java-based web application that uses Java server pages. Its primary role is to process JSP files and manage everything required to convert them into dynamic web content. When a client sends a request to a server for a JSP page, it is the JSP container that takes charge of the entire execution process. The JSP container works closely with the web server. When the web server identifies a request for a JSP file, it forwards that request directly to the container. From there, the container provides the runtime environment that JSP pages need in order to function. This environment includes the necessary libraries, JSP APIs, and system resources that allow the page to operate smoothly. One of the container's main responsibility is compilation support. When a JSP file is requested for the first time, the container translates the JSP code into a corresponding Java servlet. During this process, HTML portion of the JSP become output statements and the JSP specific tags or Java code are converted into executable Java logic. Once translated, the servlet is compiled into a class file that the server can execute. After compilation, the JSP container also manages execution support. It ensures that the generated servlet runs correctly, processes any embedded logic, interacts with the databases or backend resources if needed, and produces the final HTML output. This result is then handed back to the web server, which sends it to the client's browser. What makes a JSP container particularly powerful is its ability to understand and interpret JSP specific elements such as directives, expressions, declaration, and scriptlets. These elements allow developers to embed Java code directly into HTML, and the container ensures they work seamlessly inside the web application. In short, the JSP container acts as the engine behind JSP technology, intercepting JSP requests, translating them to servlets, compiling and executing them, and delivering dynamic web content to users efficiently. The architecture of Java Server Pages is designed to seamlessly integrate dynamic Java-based content into modern web applications. At the core of this architecture is the interaction between JSP files, the web server, and a JSP container, all working together to process user requests efficiently. In a typical web application, JSP files are stored within the application's directory structure, often under folders such as web app. These files contains HTML combined with JSP elements which allow developers to embed Java code or invoke server-side logic directly within a web page. When a user sends a request, for example by entering a URL that points to a JSP file, the web server receives this request first. The server's job is to determine the type of content being requested. Recognizing that the file is a JSP page, the web server does not process it like static HTML. Instead, it forwards the request to a specialized component known as the JSP container. The JSP container is embedded within the web server or application server such as Apache Tomcat. This container is responsible for interpreting the JSP file. If the JSP has not yet been translated or has been modified since its last processing, the container converts the JSP page into a Java servlet. This servlet is then compiled into a class file. The container ensures that the servlet is up to date and ready to run. Once, once the servlet is prepared, the request is then handed over to the servlet engine. The servlet engine executes the generated servlet, which processes any embedded logic such as database queries, condition checks, loops, or dynamic content generation. After execution, the servlet produces an output in the form of standard HTML. Finally, this generated HTML is sent back through the web server and delivered to the user's browser, where it is displayed just like any normal web page. By structuring JSP processing this way, developers benefit from faster response times, component reuse, and a clear separation between presentation and logic. This efficient pipeline is what makes JSP a powerful tool for dynamic web application development. Let us see the overview of JSP processing. When a user accesses a web page built with JSP, a series of behind-the-scenes steps take place to transform the JSP file into a dynamic HTML page. This process involves the browser, web server, JSP engine, servlet engine, and finally the browser again. Here is how it works in a simple and structured way. The process begins when the browser sends an HTTP request to the web server. This happens when the user types a URL ending with .jsp or clicks a link that points to a JSP page. The web server receives the request and immediately identifies that this is not a static HTML page. Upon detecting that the request is for a JSP file, the server does not attempt to handle it directly. Instead, it forwards the request to the JSP engine, a component responsible for understanding and processing JSP files. This engine loads the requested JSP file from the server's file system. The JSP engine then begins a crucial step, translating the JSP into servlet source code. All the HTML parts are converted into output statement and all JSP tags or Java code segments embedded in the file are turned into Java instructions. This newly generated Java code represents the dynamic behavior of the page. Next, the servlet engine steps in. It compiles the Java source code generated from the JSP into a fully functional servlet class. This class acts as a Java program capable of responding to web requests. The servlet engine then executes this servlet, allowing it to run its logic like accessing databases, performing calculation, or generating dynamic content. During execution, the servlet produces output in the form of HTML content. This HTML is what the user will eventually see in their browser. Once the servlet has finished generating the HTML, the servlet engine sends it back to the web server. The web server then returns this HTML response to the browser, completing the cycle. From the browser's point of view, it simply receives and displays a web page with no awareness of all the processing that occurred on the server. This entire sequence ensures that JSP pages can dynamically generate content based on user actions, data inputs, or backend logic, all while delivering a smooth, fast browsing experience. When a JSP page is requested for the first time or when it has been modified, the JSP engine performs an important process called translation. This process converts the JSP file into a Java servlet which the server can execute to generate dynamic content. During translation, the JSP engine reads the entire JSP file line by line. All the template text such as plain HTML, CSS or static content embedded in the page is transformed into a series of println statements inside the servlet. These statements are responsible for sending static parts of the web page as output to the browser. Meanwhile, any JSP elements such as scriptlets, expressions, declaration, directives, or custom tags are turned directly into Java code. This Java code becomes part of the servlet's logic and controls how the page behaves dynamically. For example, Java variables, conditions, loops, or method calls inside the JSP become valid executable code in the resulting servlet. Once the translation is complete, the servlet is compiled into a class file and can be executed by the servlet engine. This servlet is now capable of generating the dynamic behavior originally defined in the JSP file, such as accessing a database, displaying user-specific content, or responding to form input. Importantly, this translation step does not happen every time the JSP page is accessed. The JSP engine performs a translation only under two conditions. First one is when no servlet has been generated yet, and the second one is the JSP file has been modified after the servlet was created, making the servlet outdated. This optimization ensures that JSP pages run efficiently since translation and compilation occur only when necessary. Once a valid up-to-date servlet exists, the server simply executes it directly, resulting in faster responses for the user. Java Server Pages includes a smart optimization mechanism that significantly improves web application performance. Whenever a JSP page is requested, the JSP engine checks the file's timestamp to see if the page has been modified. If the JSP code has not changed since the last compilation, the server simply reuses the previously compiled servlet instead of recompiling it. This approach saves valuable processing time, reduces server overhead, and ensures faster responses for users. Because JSP is compiled into servlets and reused across requests, its execution is generally more efficient compared to many scripting-based technologies such as PHP, where pages are interpreted more frequently. Overall, this timestamp checking and reuse strategy helps JSP deliver better scalability, stable performance, and quicker page loading in dynamic web applications. Java Server Pages provides an easier way to build dynamic web pages by separating the presentation from the business logic. While servlets primarily handle the application logic such as processing requests, performing calculation, or interacting with the databases, JSP focuses on the visual output that users see in the browser. Even though JSP looks like a simple HTML page with embedded Java, it does not run directly in that form. Behind the scenes, the JSP file is translated into a servlet by the JSP engine. Once this translation and compilations are done, the JSP behaves exactly like any other servlet in the Java web architecture. This combination allows developers to enjoy a clean separation of concerns. JSP for layout and UI, and servlet is used for logic. In the end, both work together seamlessly to deliver dynamic, efficient web applications. When a user sends a request to a JSP page, the server follows a specific processing flow. First, the JSP file is translated into a servlet, converting all template text and embedded Java into executable Java code. Next, this translated servlet is compiled into a class file. Once compiled, the servlet runs on the server to generate the final response, producing dynamic content that is sent back to the user's browser. This process ensures efficient execution and seamless delivery of dynamic web pages. Let us see the summary of this video lecture. JSP simplifies web development by allowing developers to mix HTML for layout and Java for logic in a single file. Behind the scenes, the JSP container handles the heavy lifting. It translates JSP pages into servlet and executes them efficiently to generate dynamic content. By understanding how JSP processing works, a developer can make smarter decisions that improve performance, maintainability, and overall optimization of their web applications.